I am not looking for inequality notation for the test. I am looking for what's called interval notation. So if I tell you that x is greater than or equal to 4, that is not the answer that I'm looking for. So if you leave it as x is greater than or equal to 4 as your solution, I'm going to take a few points off of you because that's not what I want. What I'm looking for is interval notation. Now, interval notation is technically basically writing your answer as if it was a number line. So if we do a number line graph on this, here's 0, here's 4. What kind of shape do you put above 4? Open circle or closed circle? A closed circle to represent the equals. And then when you say x is greater than 4, which way do you go?
To the right.
To the right. A little trick on this. As long as the variable is first, the inequality points in the direction you want to go on a number line. As long as the variable is first. If the variable is not first, you have to flip it to get it first. Oh, and also notice the greater than symbol is actually the end of the arrow. That's where it comes from. So just, what's that noise? Sounds like a hairdryer. I don't need one. Now, for interval notation, what happens is the solid circle becomes a bracket. We're starting at the number 4, and then the comma separates it to where it goes to. Now, where is it going to?
Infinity.
The arrow says it's going off to infinity. Now, can you get to infinity?
No.
No, because once you get there, there's always
One
one more.
Put a parentheses.
So we can't contain it, so we're going to put a parentheses.
I can never do a little squiggly thing. You always just look at 8.
We'll just turn your paper upside down, draw an 8, and turn it back. That's what I used to do. All right, so that would represent greater than 4, greater than or equal to 4. If you have, oops, wrong color. If you have x is less than 2, we draw this on a number line. Here's 0, here's 2. How do you represent less than? Well, not equal to, let's put it that way. An open circle above 2. So it starts somewhere really close to 2, but it never ever touches 2. Which way does the arrow go?
To the right.
To the left, because the inequality is also pointing to the left. All right, so when we draw this into, or write it in interval notation, I'm going to start on this side, but here's the main goal. You never ever go in another order than small first, large second. You can never change that. So if I go small first, the arrow has to come first. So that is?
Negative infinity.
But it's all in the negative direction, so we call that negative infinity. We can't contain it, so we're going to give it a parentheses. And then it's going to 2. We can't contain it, so it also becomes parentheses. So it always has to go small first and large second. There is no such thing as this. That's a point.
Wait, wow. I do have one question. The 2, what do you mean? You can't contain it because it's not equal
Not
to?
equal to.
Okay, I get it now.
It's not contained in the.
I had to say it out loud.
Okay. So you can't write things as 4, -3 or bracket 4 to -3. This makes no sense because it's supposed to go small to large. So those are written wrong. You have to write it -3 to 4. Now the other thing that gets a little messy is, what if it's not contained and I have -3 to 4? What does that look like? It looks like a point. It looks like I'm going to go left 3 and up 4. But that's not what this is talking about. These are just talking about x values, the x-axis, horizontal. So if we get confused with this, we can always add in x is an element of, to remind us that those numbers are both x, not x and y. Right. Another type of notation, double inequality. Oh, -5 is less than x is less than or equal to 4. When you see a double inequality, it actually is shorthand notation. Technically, it's illegal to write things like this, but it's just a mathematical shorthand. You always what?
Have to separate it like.
Yeah, you can. This can get separated into 2 pieces if you wish. I usually don't. But this is x is greater than -5 and That's the key word here. X is less than or equal to 4.
It just helps with my sign, like the way the arrow is pointing kind of helps with it.
I like the way it's written in the beginning because you say it in one sentence and you know what you're talking about. If you're greater than -5 and less than 4, where are you? In between them. So when you see this notation, a fancy way of saying it is between. X is between -5 and 4. And then you can deal with the equality or non-equality at the endpoints. Either way, we're going to get a number line that starts at -5, ends at 4. What goes above -5?
The open circle.
Open circle. What goes above 4?
Closed circle.
Closed circle. I always had teachers that made you draw it right on the line,
Yeah,
and you could
that's what
never
I was
see
gonna
your
ask.
solution.
Does it matter? Would you rather have it up above it?
I'd rather have it up above it because then you can see where you're going.
Yeah.
And between literally means between, and you stop. So they actually become like a line segment. All right, so it starts at -5 and ends at 4, and you always read interval notation from left to right. So this becomes parentheses, -5, comma, +4, bracket. And that still means the exact same thing as all the stuff above it. So this is interval notation. Get used to it.
Pretty easy once you get a hang of it.
Yeah, the biggest mistake people make is writing this as 4 -5. They read it backwards. It always has to go left to right on the number line. Has to.
Oh, which? Never mind.
Alright, ugly equation. For example, 3 minus 4x plus 5 divided by 6 equal, greater than or equal to 4 plus 5 minus 2x over 3. Little review problem. Going back to solving equations, solving linear type equations. Alright, you see this linear type equation. What's your first instinct?
GCF.
GCF. How many of you take the fractions and write them out front? How many of you should? About 50% of you. You know what I mean by taking the fractions and writing them out front, right? Write this as 3 minus, this 6 really represents 1/6, parentheses, 4x plus 5 is greater than or equal to 4 plus 1/3 times the quantity 5 minus 2x. The one reason I'd rather you do the blue step than not is even in my other class when they were doing some of their review work, they didn't take that negative and distribute it to that 5 because they don't see the parentheses. They don't see the parentheses at all. So if you write it as a number out front and parentheses after, you know that distribution has to happen. So I implore you, if you see a fraction that looks like this, just write it as a fraction out front times the top.
So they're in the window.
I'm doing something. Okay, so we're going to multiply through by the GCF, which happens to be 6. Whether the black one or the blue one, the answer should turn out to be exactly the same. So multiply this one by 6, multiply this side by 6, and distribute it through. The other reason I like this is because when you get to 6 times 1/6, your answer is 1, and then you just distribute that instead of thinking that you have to multiply top and bottom, which really annoys me. So after I distribute the 6, well, keep it in. 6 times 3?
It's 18.
6 times 1/6
It's 1.
is 1, parentheses, 4x plus 5. That doesn't get touched because it's inside of parentheses. Over here, 6 times 4
24.
plus 1/3 times 6.
2.
2, and left behind is 5 minus 2x. Yay! So we got rid of the fractions. That's the first step of trying to solve a linear equation. Second step, distribute. So this becomes 18 minus 4x minus 5 is greater than or equal to 24 plus 10 minus 4x. Be very, very careful of your signs, especially when distributing a negative number. All right, next step. So this is negative 4x plus 13 is greater than or equal to 34 minus 4x. Uh-oh. Darn it.
What happened?
No, what I didn't want to happen. What happens to the 4x's?
They
Cancel
can't.
out.
We got to fix that because I don't want them to cancel out because then I don't have any x's to solve for and there is no solution. So I'm going to go back to the beginning and do one change. Change this to plus 2x. I don't want no solution. I want an answer out of this.
Why can't we just done this one? There's no solution.
No, because I went through all this work and I don't want a no solution one. None of my tests are going to be no solution.
Huh.
All right. So no, you cannot do this on the test. I just changed the problem from the beginning. The chances of this happening by just making up numbers, rare, but it does happen. All right, how do I solve this inequality?
Get one in the variable by itself.
Get the variable on one side. Don't get it by itself because you can't right now.
Okay.
So which one do you want to move?
The 4x.
All right, so subtract 4x from both sides. Personally, I would have added 4x, but that's okay. And we will get
Negative 8x.
13 is greater, negative 8x plus 13 is greater than or equal to 34.
Because when you divide by a negative, don't you have to flip
We're getting there. I'm glad you went the way you did because I can talk about that then. We'll get there. All right, what would you do next?
Subtract 13.
Subtract 13. Notice I'm showing all my nice little stuff.
Thank you.
Yeah, thank you.
It'll go away eventually. And this leaves us with negative 8x. How about this? I'll show the steps if you can tell me what property I just did.
What property?
From here to here.
The identity.
I did
That's
it
one of them.
inverse.
Inverse identity.
So
Inverse first because negative 13 on top of 13 becomes
I'm
0.
gonna hold you up to it now.
The rest of the class I'll be showing every little step. 2 times 3 is 2 plus 2 plus 2. 34 minus 13
It's 21.
is 21. Last step?
Divide by
Divide by
negative.
-8.
Now I gotta go off to the side and do a little description now. I have to ask a silly little question. Is 2 less than 5?
Yeah.
True or false?
True.
I hope that's true. If I multiply both sides by a -1, I get -2 and -5.
Mhm.
But what's the comparison between them now?
Now
Negative
negative 2
2
is the greater
than.
number.
So if you multiply or divide by a negative, the inequality has to
Change.
flip. It has to adjust itself. So because I divided by -8, this is going to become x is
Less than or equal.
less than or equal to
Negative.
21/8. Yeah, not very pretty.
Like 2.62.
No, I don't care what it is. I don't do decimals. I like exact answers. Okay. So if I change this into interval notation, whether you do it number line style or not, this would be, here's 0, here's -21/8. What kind of circle?
Close.
Close. Which way would it be pointing?
To the right. I mean to the left.
To the
I need
left.
Shut up.
Interval notation then starts with a parentheses. Negative infinity because it's going way to the left, comma, -21/8, bracket. And this is the solution I'm looking for. Because I will say on my test, give me the interval notation solution.
What if we give you all three?
So,
Well, you're going to give me all 3 of them anyways, but the only one I really
You
want
want-
is the interval notation. And it better be right.
That comma represents, not comma, but the bar parenthesis represents what now?
Not
Open circle.
included. Not included.
Yeah.
Or open circle if you want to think of it. But technically it's not included. The parentheses on the infinity is so you cannot contain it. The parentheses on a number just means it gets really, really close to that number, but it never ever touches it.
It's cold.
Warmer in here than it was yesterday.
Hello.
Yesterday I was having icicles form on me. Alright.
How about all that frost on the
Now,
windows
when
this
did
morning?
you just say that you're going to require all 3 of these answers?
No. I just want the interval notation. So,
Which is the...
well, you're going to get the inequality one.
Yeah.
If you want to skip the number line, that's fine.
Okay.
But if you have a hard time with interval notation,
For
No.
visualization.
put that in there for visualization so you go left to right.
it's a close. When it's just greater than or less than, it's an open circle.
But that is inclusive.
Yeah, because it's greater
Something
than
different.
But then.
Well, not really.
Yeah,
It's
because
absolute
the-
value interval notation.
That means.
Mhm.
Well, absolute value inequalities with interval notation.
Yeah.
All right, back to absolute value equations. Now I have a choice on the test to either give you an absolute value equation or an absolute value inequality. Guess which one do I lean towards?
Inequality.
Inequality, because it has a little bit more tricksterism to it, but it still asks, you to do the same type of solving. So, for example, if I give you 3x minus 5 is greater or equal to, I don't know, 7. Remember, make sure your absolute values are bigger than a 1, so you don't ever read that as 13. So if you have to exaggerate them, go right ahead, exaggerate away. What is the first step of solving this inequality? Separate it into a positive part and a negative part. So your assumption is going to be, well, 3x minus 5 is either going to be a positive value or 3x minus 5 is going to be a negative value. All right. If it's positive, 3x minus 5 just pops out by the definition of absolute values. It's going to stay greater and equal to 7. Okay. If it's negative,
Negative 7.
no, I don't do that.
Oh, you don't do that?
Oh my gosh, no, I go by definition only. If the answer in the inside is negative, like, negative 5 or something, then you take the opposite of it.
I was taught to do negative 7.
You can, but I swear there's going to be a screw up there eventually.
Okay, so I need to switch my way.
No, you can do it that way. I don't mind which way you do it as long as you get the right answer.
Okay.
Okay. All right, solve this one like you normally would. What would you do first? Add 5 to both sides. Then you get 3x is greater or equal to 12. Divide both sides by 3. Then you get x is greater or equal to 4. Yay! So far, so good?
Mm-hmm.
This side, you would subtract 5 from both sides, so you get negative 3x is greater or equal to 2. Divide both sides by negative 3, and you get x is less than or equal to negative 2/3. That's why I don't like multiplying the other side by negative. Too many people forget about that part right there. Now, I have a problem. I have 2 answers, and they're pointing, I don't know where they're pointing. I'm not really worried about it. I want you to get used to this idea. We're going to do what's called a number line test to find where the solution is. This number line is getting cut at 4, and it's getting cut at negative 2/3. Make sure you put your numbers on it in the correct order, smallest to the left, biggest to the right. And it cuts the number line into 3 pieces. And all I'm going to do is test each one of the pieces. In other words, pick a number that is smaller than negative 2/3, so we can talk to the left of it. What's a number that's smaller than negative 2/3?
2/4.
Don't be ugly. Make it nice. How many numbers are less than negative 2/3?
Infinite.
Pick one.
Okay.
Negative 1/3.
Negative 1/3 is not to the left. That's to the right. Pick a nice number to the left.
Negative 5.
Negative 5, negative 100, negative 2, negative 1.
Negative 1.
I pick negative 1 personally. So if you choose x is equal to negative 1, go back to the inequality, plug it in, and see what happens. 3 times negative 1. Negative 3 minus 5. Negative 8 absolute value.
Is 8.
Is 8 bigger than 7?
Yes.
Yes.
So it's going to work on that interval. For all the numbers. Negative 100, negative 200, all of them. Pick a number between negative 2/3 and 4. Oh my god, this is going to be hard. 0 would be the best one, but 1 would work too. So let's choose 1 just to be different. 3 times 1?
It's 3.
3 minus 5?
Negative 2.
Absolute value negative 2?
2.
2 bigger than 7?
No.
So this is not going to give me any solutions. So no number between negative 2/3 and 4 is going to work. It's not part of my answer. Pick a number bigger than 4.
5.
Yeah, that was easy, right? 5. 3 times 5?
15.
15 minus 5?
10.
Absolute value of 10 is bigger than 7?
Yes.
Yeah, so that's part of my solution also. So what's my final answer? Well, my final answer is going to be the interval to the left of negative 2/3.
It's
How do I write that in interval notation? It's going to start off with a parentheses,
negative infinity.
negative infinity, comma,
Negative 2.
it stops at negative 2/3,
Bracket.
bracket, why bracket?
Because it's an open circle.
Why is no,
I mean, close.
Closed circle because it is
Greater than.
or equal to. The equal to gives you the bracket. Union, that symbol just means I have more than one piece.
Right.
My second piece starts where?
A bracket.
Bracket, what number?
-2/3.
4.
Why not -2/3?
I stopped at -2/3. It doesn't work between -2/3 and 4. I don't want those numbers. So it starts up again as 4, and it goes off to
Infinity.
parentheses. That's our answer. All of those numbers will work. Between -2/3 and 4 are the numbers that don't work. So basically, we cut the number line and remove that piece.
That U means what?
Union. Put the pieces together. Another word for it, if you want to use a word, is or. Remember that double inequality? I used the word and to mean between. Or means not between, away. Because if you try to use and in between these two, there's no number that is less than -2/3 than bigger than 4. You would have no solution at all. But by saying or, you're saying it's this one or it's that one. But if you want to use or between them, that'll be fine. But union is just quicker. A little u and you're done. All right, how about this one? -2, absolute value of 4 minus 5x, absolute value plus 5 is equal to -7. Oh, not equal to. Oh.
Greater than.
I did greater than already.
Less than.
But I want to do greater than.
Greater.
There's a reason. Greater than equal to or greater than, it works out the same. What should I do first?
Add 5 on both sides?
Nope. Subtract 5 from both sides.
Okay.
I was wondering why you got that. So subtract 5 from both sides. And you get whatever's left over, -2 times the absolute value of 4 minus 5x is greater than equal to -12. Subtracting a number across does not change the inequality. I've had people do that. They see the little minus sign and they're like, oh, flip the inequality. Only do that under multiplication or division. Like, for instance, now. Divide both sides by? -2. If you divide both sides by -2, this side becomes 4 minus 5x, all absolute value, is less than or equal to 6. Oh, question, and I forgot to ask it. Can you distribute -2 through the absolute value?
No.
Please don't. Distribution does not work over absolute value sign. They're not parentheses. They're bars, football goals. Don't think distribution works. It doesn't all the time. All right, now we're going to make that assumption that the inside is either positive or the inside is a negative number. Negative value. If the inside is positive, it comes out as 4 minus 5x is less than or equal to 6. If the inside is negative, it comes out as
Positive. -4
-4
plus 5x
plus 5x
is less than or equal to negative.
less than or equal to 6. Don't change both sides, just one.
Okay.
Okay, and then this one's easy enough. Subtract 4. You get -5x is less than or equal to, what's that, 2?
2.
2. Divide both sides by -5.
X is greater than or equal to.
And don't forget to switch to inequality. So x is greater than or equal to
-2/5.
Okay. Over here, add 4, and we get 5x's.
Less than or equal to 10.
Divide by 5, and x is less than or equal to 2. Yay! So again, we have these two solutions, and we need to figure out what they're really talking about. So if you draw a little number line, put your solutions on there, which are -2/5 and 2. Oh, by the way, the reason this works is 2 is what makes it equal to 0, and -2/5 is another thing that makes it equal to 0. What does 0 do to a number line?
It connects them or
Connects what?
The negatives and
The negatives are on the left and the positives are on the right. It's a divider. It's a divider. So this is dividing a positive and negative side, and this is also dividing a negative and positive side. And how they mix and match together gives us our answer. So pick a number smaller than negative 2/5.
1. Negative 1.
Negative 1. So I plug it in. Now, you can go to the original one, but that's kind of horrid. I would go to your simplified one down here. Plug it in here. So if I take negative 1 and plug it in here, you get negative 5 times negative 1. 4 plus 5. Is 9 less than 6?
No.
Nope, that's not going to work. So I don't want any answers from down there. Pick a number between negative 2/5 and 2.
1. 0.
Anything between a negative and a positive, I would pick 0, but you can pick 1. 5 times 0? 4 minus 0? 4 less than 6?
Yes.
Yep. Well, technically absolute value of 4, but we know that's going to be 4. Pick a number bigger than 2.
3.
3. If I plug in 3, it's 5 times 3 is 15. 4 minus 15 is
11.
negative 11's absolute value. Oh, I'm sorry, down here. Absolute value is 11. Is 11 less than 6?
No.
No. So the only answer here is literally
Between.
between. Between. So how do I write that in interval notation? It starts at
Parentheses. No. Negative.
negative 2/5. Is it a parentheses?
It's a bracket.
Why is it bracket?
Because.
Because it has equal sign associated with it.
Right.
So this will be bracket, comma, no,
No. To 2.
to 2, bracket. Because it stops at negative 2/5. It only works from here to here.
Right.
It doesn't work to the left or to the
Right.
right. And there's your answer. Now, there is a shortcut way of doing this. If you do enough of them, you start recognizing that greater than is always pointing away from the middle, and this one is actually a less than would be pointing towards the middle. So you'd be going between for less than and a union for greater than. But that's shortcut language, and you got to be careful because this started off with a greater than. So don't make any assumptions. If you get lost, the number line is the easiest way out. And plus, it helps you in chapter 3 when we do weirder stuff with inequalities.